Welcome to my video on proportional relationships. So when two quantities x and y vary in such a way that one of them is a constant multiple of the other, the two quantities are proportional. In other words, the rule can be determined by multiplying the x value by the same number to achieve the y value. So in other words, when you're comparing the x to the y, you're looking for a multiplying pattern. So there are two ways to determine a proportional relationship. See if you multiplied or divided each x value by the same amount to get the corresponding y value. And then the second way is see if the ratio of y over x, in other words, the slope change in y over change in x, is equivalent for all of the ratios. So we're comparing the y to the x and seeing if it's equivalent for all the ratios. If it is, then it's a proportional relationship. And the slope will be that number. Okay, let's look at an example, a real world example. Veterinarians say that 1 year of a dog's life is equivalent to 7 years of a human life. Complete the table. So in other words, if a dog is 1, they're said to be 7 in human years. So following that pattern, if a dog is 2, then in human years it would really be 14. And when a dog is 3, in human years it would be 21. When a dog is 4, in human years it would be 28. When a dog is 5, 7 more years would be 35. And when a dog is 6, it is said to be 42 years as a human. Okay, that's why it doesn't seem like dogs live very long when they live for 14 years, but in human years that would be 98. So that is quite a long time. So is this a proportional relationship? Well, we need to compare the x to the y, and are we multiplying by the same number each time? And the answer is yes. You can see that we are multiplying by 7 each time. Now, another way to look at it too is you can do the ratio of the y to the x. So I can do 7 over 1. And 7 divided by 1 would be 7. Let's look at a couple other ones. We're not going to look at every single one. 14 over 2. Is 14 over 2 simplified to 7? It sure does. And let's look at one more. 21 over 3. Yes, that does simplify to 7. And the others will also simplify to 7 as well. And that means that the rule is that you're multiplying by 7. So we would write this as 7x because you're multiplying all the x values by 7. And we put number in front of letter for multiplication. Let's look at another real world example here. And we have Matthew is 4 years older than his sister, Ashley. The following table shows the relationship between their ages at given points in time. So when Ashley is 4, if Matthew's 4 years older, then he would be what? Good, 8. When Ashley is 5, Matthew would be 9. And then 4 more than 6 would be 10. And 4 more than 7 would be 11. and 4 more would be 15. So is this a proportional relationship? Well, it looks like we're multiplying here because 4 times 2 is 8. But let's see if we multiply by 2 here. Is 5 times 2 9? No. Is 6 times 2 10? No. So it's not times 2. So if you're not multiplying by the same number all the way through, then it's not proportional. So this is no. This is not proportional. So now we've got to figure out the rule. And I can also show, well, before I figure out the rule, let me show that it's also not proportional by comparing the y over x, because that was another way we learned above. And let's look at a couple. 8 divided by 4 is what? 2, right? Is 9 divided by 5 2? No. And then I could go on and on. Is 10 divided by 5, 10 divided by 6? No. 11 divided by 7? No. Okay, as soon as I get one that isn't the same ratio, then I know it's not proportional. So, what is the rule? What are we doing to the x value each time? So, when we write an equation, we list the x first, and we could be multiplying the x by something, but we are definitely not multiplying the x by anything here. We are actually doing what to the x each time? We're adding 4. So the rule would be y equals x plus 4, because I'm adding 4 each time. Now, let's look at the rate of change or the slope, and we've already talked about this in terms of graphing. So the slope of a line is a rate of change, and it's a ratio describing the vertical change to the horizontal change of the line. The slope of a proportional relationship can be determined by finding the unit rate. And remember, slope is how steep your line is on the graph. So we talked about this the other day. Slope is change in y over change in x, or the vertical change over the horizontal change. And we could also say rise over run. Okay, the graph of the line representing a proportional relationship will include the origin, 0, 0. Because if it's a multiplication pattern, okay, no matter what number you multiply, you're multiplying by. You could be multiplying by 6, 8, 9, 10, 11, negative 1, 6, 1, 6, whatever you're multiplying by. The slope in a proportional, whatever you're multiplying by, when you plug in 0, you'll always get 0. 0 times anything is 0. So that's why in a proportional relationship, it's always going to go through 0. Because let's say the equation was y equals 6 times x. Well, when you plug in 0 for the x, 6 times 0 equals 0. So the x and the y would both be 0. The slope in a proportional relationship can also be referred to as the constant of proportionality. And that's because you're constantly multiplying by the same number each time. Okay, let's look at a real world example. And it says Taylor bought 4 king size candy bars at the store for $10. What is the rate of change? In other words, what is the cost per candy bar? Complete the table and graph. So what we can do here is we only have one piece of information. We know that Taylor bought 4 king size candy bars for $10. So what we can do is we can actually find the unit rate. Because remember, the unit rate is how much for one. So if we want to know the cost per candy bar, that means that we could divide the cost by the candy bars. Okay, and this goes for any unit rate you would have, like miles per hour. You would do miles divided by hours. So in other words, whatever it starts with, that's the number that's going to go on top. So cost per candy bar, miles per hour, ounces per week, dollars per week, dollars per hour. Whatever comes first goes on top. So in this case, we want to know the cost per candy bar, so we're going to put the $10 on top of the 4 candy bars. So we're going to divide by 4 candy bars. And 10 divided by 4 is 2.5. But since this is money, we're going to write it as $2.50 per candy bar. So whenever you're writing a unit rate, you always want to write it with a label. Okay, so that means 1 candy bar is $2.50. Now, how much would 0 candy bars be? Yeah, 0. So if we know how much 1 candy bar is, then we can figure out how much 2 candy bars are. So if each one is $2.50, then 2 candy bars will be $5. And then 3 candy bars would be $7.50. And then 4 candy bars would be $10. Now we can graph this on our grid: 0, 0, 1, and 2.5, 2 and 5, and 3, so go over to 3 and up to 7.5, so go right between 7 and 8, and then over 4 and up to 10. Okay, so what you're going to have to do when you're graphing these is count. The numbers are really hard to see on the screen. Hopefully you can see them a little bit better on your paper, but if you can't, you can write them bigger on the side and go all the way up. Now, this would be helpful to have a ruler so that we can connect the points. And notice I'm not putting an arrow in both directions because we can't have negative candy bars. So we actually have a ray here, and it's only going on and on in this direction, okay? Because we can't have negative candy bars. But I could figure out the cost of 6, I could figure out the cost of 10, 20, etc., etc. Okay, now, the rate of change is another word for saying what is the slope, okay? And it's also another way of describing the unit rate as well. So what I could do, I could also use the graph as well, and we started with up 10 over 4, and up 10 over 4 would give us 2.5. But we could also leave it as a fraction too, and we'll write it when we get down here, because we can actually go up 5 over 2. And we want to try to have a rise and a run that end up integers most of the time, because sometimes it's very difficult to graph in between. Okay, so let's look at the rate of change. So it's exactly the same as the unit rate. So we're just going to say $2.50 per candy bar. And slope will be the same, but we're not going to have a label for slope. We just call it a number, so we're going to call the slope 2.5. But remember, and I want you to write this down, we originally started with 10 over 4. So we could simplify that by dividing top and bottom by 2. And you can also write slope as a fraction. And slope as a fraction is the main way you're going to see it on a graph. Now in word problems, sometimes that's a little bit different, but when you were doing just a straight up graph like we did the other day, you'll see it as a fraction, so that we have a rise and a run. So we can have it 2.5 or 5 over 2. So you would have to be looking for both answers. Okay. All right, let's move on to the last page. And let's see here. Let me fix this. That is my dog barking, so don't mind him. And it says, find the rate of change or the slope of the tables below. Now I asked two questions, rate of change and slope. And we know that rate of change is another word for slope, so we're going to write the same answer on both lines. I want you to know that they mean the same thing. So what we're going to do is very similar to what we did when we did graphing. Okay, when we did graphing, we did rise over run. Well, when we have a table, we're going to do rise over run. We just don't have a picture. Okay, so we're going to use the table to do the rise over the run. So if I was actually on a graph, I would go from -4 to -2. So my rise, would it be positive or negative? Good, it would be positive because I went up from -4 to -2. Now my run goes up from -2 to -1, so my run would be +1. Now I'm going to check this one. These are two other points, and my rise would be 2, once again, and my run would be 1. Now my rise would be 2, and my run would be 1. And notice all the ratios are the same. So remember, slope is change in y over change in x. So I'm just going to circle the one that I'm using because sometimes they are different. Remember, it's change, write this down, change in y over change in x. So we would actually write 2 over 1 because the change of the y was 2 and the change in the x was 1. And what's 2 divided by 1? It's 2. So the slope would also be 2. Okay, now, the ratios won't always appear to be the same. So let's look at number 3 because they're not all going to look the same. But let's see what happens. So once again, we have a table. So we're going to do change in y over change in x. So we went from 6 to 0. So we actually went down 6, so that would be down -6. And then my run is going from -4 to 0, so it went up 4. Now 0 to -3, it went down 3. And 0 to 2, it actually went up 2. -3 to -6 went down 3. And 2 to 4 went up 2. So notice these two are the same, but this one appears different. So let's circle it and see what happens. So we're going to do change in y over change in x. Now my change in y is -6. My change in x is 4. So what can I divide top and bottom by to simplify? Because I always have to make sure I simplify my slope. And I can divide top and bottom by 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2. But remember, this is negative, so if my slope is negative, I have to leave the negative in front of the fraction. So this would be -3 over 2. And the slope is also -3 over 2. Now look, it appeared that they were different, but they all came out to be -3 over 2. So why is that? Well, look what I'm counting by here. I'm counting by 2's. But here, I skipped -2. So that's why the ratio changed, but was still equivalent. Because I did the same change. Okay, I skipped it, but then I kept the pattern going. Okay, so that will happen. I can skip numbers, but as long as I keep the same pattern going, it will still be correct. And this pattern, in case you didn't notice, is actually times -3 over 2. If you compare the x to the y, I'm actually multiplying by -3 over 2. Okay, let's look at the last two examples. Number 4, This time, all my y's are the same. So if you remember something about slope, you wouldn't even have to calculate this, but let's calculate it anyway so I can show you. So these are all changes in 0. This change is 2, this change is 1, and this change is 2. Now notice I didn't put plus 0 or minus 0 because 0 is neutral, so it can't be negative or positive, so I just put a 0 change. And so we're going to do change in y over change in x. Now it appears that it's different, but look, okay, I'm going to circle this one, and we're going to do 0 over 2, because change in y over change in x, and what's 0 divided by 2? Is 0. So the slope is also 0. Now look at this one. This one's the same, 0 divided by 2, but this one's still the same. 0 divided by 1 is still equal to 0. Okay, and our last one. We have a change of 2.7, went up by 2.7. This one went up by 1. The change in y here is 5.4. And the x change is 2. And then the y change here is 2.7. And the x change is 1. Now, these two are the same. This one looks different, so I'm going to check it out to be sure. So, change, whoops, let me, forgot to write this to remind you, change in y over change in x, and we can do 5.4 divided by 2. And what is 5.4 divided by 2? It's 2.7. So when the pattern's a decimal, you will sometimes see your rate of change or the slope is a decimal, but I will also show you how you can actually change this to a fraction. So check this out. If I move this, this is really 2.7 over 1. So I can move the decimal one place to the right and change that to 27. And if I do that, I would change 1 and move it 1 to the right. Well, if I have one whole and I move it 1 to the right, I add in a 0. So that would actually be 27 tenths. So I could actually write both. That is my phone ringing, so just ignore that. So 5.4 divided by 2 was 2.7. Well, 2.7 divided by 1 is also 2.7. So that concludes our notes on proportional relationships. I hope you have a great day.